Welcome one and all to the Math Magic Show. What we're going to do is find the equation of every tangent line ever. So specifically to the curve 1 over x. So I have here 1 f of x equals 1 over x. And to go through that process, I'm going to first differentiate, as you might remember. So it's helpful before doing that to rewrite this quantity as x to the negative first. And then you can see that the power rule is what is applicable here. So I'm going to have now f prime of x. And the power rule states that you take this negative 1, you place it out front, and then you subtract 1 from it. So I'm going to have negative 1, x to the negative second. And then I clean this up, for example, simply by rewriting it as negative 1 over x squared. So this is the derivative, f prime of x. And now we don't have a point. So when we don't have a point, you can represent one in a kind of general sense simply by writing it this way. That, for example, a is the value of x. So if you plug that into the function, you would have f of a, which would simply be 1 over a. So this would be 1 over a in this position right here. This is our point. We don't know the value of x, it doesn't matter. We don't know the value, therefore, of 1 over a. So what I mean is, specifically take a look. It's as if we had an arbitrary point on this graph, some point somewhere. This is one of the portions of 1 over x. So for example, let me just choose this arbitrary point. So at that point, for example, x is the value a, and when you plug it into the function, you get 1 over a as the y-coordinate. Don't forget something important here, that despite appearances, despite everything, this is really just x, and this is really just y. So in other words, if I made a line straight down, this is my a, it's just a value of x, and this here is 1 over a, but again, that's really, as you can see, it's just a value of y. So that's all they are. Let's get back over here and make use of this information. So I have my point, I have the derivative. To build up the equation of every tangent line ever, let's just remind ourselves of what that looks like. So we'll have the tangent line takes this form right here. So I have tangent line equals y minus that particular value of y. So that is 1 over a. And then this is equal to the slope at that point, but the derivative at x equals a is the slope. That's the purpose of the derivative. So it becomes negative 1 over a squared. What I'm doing right here is I'm just replacing x with a. Just like here, I replaced y with 1 over a. Remember that the equation of the tangent line is based on this simpler equation. Just to remind you, that looks like this. Y minus y1 equals m, and then x minus x1. That's all it is if you think about it. So in our case, it just happens that y1 is 1 over a, m is just the slope, it's just the value of the derivative, and then x1 is a. That's all it is. It comes from the simple stuff. So now I will have here x minus a. We definitely want to clean this up, make it look a little better than this. So let's work on that a tiny amount. Let me just slide over, and I will have now y minus 1 over a equals. Let's be careful because you have to distribute. So we're going to distribute this over to here, and then I'm going to distribute it over to the negative a also. So I will have negative 1 over a squared x, and then I'm going to multiply this negative by that negative, and that will give me a positive, needless to say. So plus a over a squared. Now the a over a squared, as you can see, clearly has a common factor that you can cancel off between top and the bottom. So I'm going to have now y minus 1 over a equals negative 1 over a squared x. So here, let me just clarify this point, clean that up a tiny amount. That's really a times a, correct? Which means that this one can be cancelled with this one. So 1 over a is all that remains. So it becomes plus 1 over a. But now, you see this is negative 1 over a on this side, so I can just shift that over to addition. So a, cancel, cancel, plus 1 over a. Tally up the results straight down. So y equals negative 1 over a squared x plus 2 over a. And this is indeed our masterpiece. This is the equation of every tangent line ever. What that means, of course, is that a represents an arbitrary value of x, except, as I'm sure you know, x equals 0, because 1 over 0 is not defined. So let's actually make use of this formula and apply it just one time. You want to make sure that, when we develop these beautiful, powerful, all-encompassing magical formulas, that they work in a specific case. So let's see here. I'm going to use this point, -1, -1. So right here, I'm going to use -1 and -1. So that's -1 and -1. So this is like my a, and this is my y, basically. In other words, 1 over a. So I'm going to plug into that formula. So I'm going to have y equals negative. Now look, the formula has -1 over a squared. In our case, a is -1. So it gives me the following. -1 squared x. Be careful with all of the little negatives, they can really trip you up. And then at the end, what was that? Plus 2a. So I'm going to put here plus 2 over the value of a, but again, the a is -1. Let's clean this up a tiny amount. So y equals negative. Now the -1 squared is +1. Then you multiply by the negative on the outside. That's going to give you negative x minus 2. And then here, this is indeed the equation of the tangent line at that point. So if I were to draw that in there, it would roughly speaking look like this. And what we have just found is the equation of that line. Well, thank you for spending some time with me and allowing yourself to be trapped in the fascinating and deep world of mathematics, just the way I am right now, all around me. Please leave a like and subscribe, and I'll see you in another video.